Hi, I'm George Norrie, and welcome to our Coast to Coast AM YouTube channel. Have fun, tell your friends, and share us with everyone. You can also find us on Facebook, Twitter, Instagram, TikTok, and Coast to Coast AM's mobile app. And always remember to log on to our website at coasttocoastam.com for daily articles, the best paranormal information, and all you need to know about your favorite guests. And now you can become a Coast Insider directly through the Coast mobile app. We welcome our international listeners and even offer a free 2-week trial. So don't delay. Become an insider today. Former Navy pilot and Americans for Safe Aerospace Executive Director Ryan Graves reacted to the historic hearings yesterday on UFOs, calling it an inflection point, referring to UAPs, unidentified aerial phenomena. Clips of Graves and two other whistleblowers, David Fravor, former commanding officer in the Navy, and David Grush, the U.S. Air Force officer and former intelligence official, have gone viral after they gave sworn testimony in front of Congress as the personal experiences of what many Americans would describe as UFOs. Kevin Randle, of course, would definitely call them UFOs, wouldn't you, Kev?
What did you say, George? I missed the first part of that.
You'd call them UFOs.
Oh, yes, UFOs. When you switched me into the phone, there was a sound and I didn't hear the UFO part.
What'd you think of the hearing?
Well, I did sit through the whole UAP congressional hearings yesterday, and no, unlike so many of my colleagues, I was unimpressed.
Really? Why?
I heard and saw nothing new here. I knew days ago who the witnesses would be and hoped that some of David Grush's sources would be revealed. With hints about sources, we could have begun the process of verification, but without them, we just have some interesting tales that might be more fiction than fact.
All right, my friend, what do you have for us this week?
Well, here are some of the things that I noticed during the hearings. There was a great deal of talk about transparency, but little talk about sources, sightings, or results. There was a great deal of talk about national security, and most of us could figure out what that meant. Revelation that the U.S. was in possession of alien spacecraft, or rather proof of that, could certainly affect national security. Our competitors in the world would fear that we might learn about the operation of the alien spacecraft and what sort of advantage that would give us. Representative Dave Grothman, who chaired the panel, asked if witnesses thought the UAP posed a threat to national security, and Commander David Fravor, the Navy pilot involved with the Tic Tac sighting, said yes. Another of the representatives asked if he, Grush, had met with people with a direct knowledge of non-human craft. Grush said that he had personally interviewed those individuals but provided no names or sources. On the other hand, Don Schmitt, Tom Carey, and I have interviewed first-hand witnesses. We talked with former counterintelligence agents who had direct knowledge, and we've also talked with civilians who had specific and direct knowledge, such as Bill Brazel. Without the witness names and other sources, there's little that we can do to validate the claims made. And as I say, I hoped for a little more detail. Ryan Graves, one of the witnesses, did mention a sighting at Edwards Air Force Base. The witnesses to the sighting were civilian contractors talking about a huge object. He didn't provide much in the way of detail, but it did remind me of a somewhat similar sighting that took place for tonight's retro case. Charles Moore, yes, he of mogul fame, made a UFO report to Project Blue Book. The sighting near Array, New Mexico on April 24th, 1949 is multiple witness and used instrumentality to observe the object. Moore, along with a crew from General Mills, were launching balloons. They released a 350-gram balloon about 10:20 a.m. Mountain Standard Time and were following it with a standard telescope. Moore made a reading at 10:30 a.m. Moore later said that he thought that he had the balloon in sight when he picked up a whitish spherical object that was drifting east rapidly. When the distance between the ground station and the supposed balloon became apparent, he took over the telescope and found the true balloon was still there. The object was ellipsoid, white in color except for the light yellow on one of the sides, as though it was in a shadow. He saw no good detail. They lost sight of the object in the distance after watching it for about 60 seconds. They made measurements using the equipment and stopwatch, but they took no photographs. They reported the sighting, and it became part of the Project Blue Book files. Originally, it was classified secret, but it was downgraded later in accordance with regulations. and it is one of the unidentified sightings in the file. And that's what we have for tonight, George.
All right, Kev, we'll talk to you next week, my friend. Kevin Randall, who monitors UFO reports for us. Up next, Michael Rampino back with us. Will an asteroid take us out one day? That's just one of the things we'll talk about with him next on Coast to Coast AM. And welcome back to Coast. George Noory with you. Michael Rampino back with us. Michael is a professor of biology and environmental studies at New York University. He's been a consultant for NASA, is the editor of Climate, History, Curiosity, and Predictability, and co-authors of Origins of Life in the Universe. And here he is back on Coast to Coast. Hi, Michael. How have you been?
I've been fine, George.
Good to talk to you. What do you think of this heat wave that's hitting the globe? My God.
Well, George, I worked in climate research back in the 1980s, and we were doing climate modeling, simulations of what the climate would be, 20, 30, 40 years in the future. And the calculations that we did at the time and we published for what things would be like in the 2020s were exactly right on to what's happening now. So it's not a surprise to most climate scientists who follow the literature and know the science that we're seeing these kinds of temperatures. It's just what we predicted would happen with the increasing amounts of greenhouse gases that we've been putting in the atmosphere basically by burning fossil fuels. So it's no surprise.
Is anything, Michael, also happening to the sun? Is it getting warmer?
No, the sun, there's no indication that the amount of solar energy coming from the sun is changing. The change is in the amount of greenhouse gases in the atmosphere. It's very simple physics. The more greenhouse gases you put into the atmosphere, the warmer the climate gets. It's very, very, very straightforward, simple physics. And we've been pouring CO2 and other greenhouse gases into the atmosphere now for decades. And as I said, 40 years ago, 35 years ago, we did the science, we did the calculations of what the situation would be if we kept on pouring greenhouse gases into the atmosphere. And the results were, if you read those reports, it's almost like reading the newspapers today. These heat waves and fires and ocean temperatures, 100-degree ocean temperatures off of Florida, all those things were predicted by the science back, as I say, in the 1980s. And if people had taken those predictions more seriously, maybe we'd be 40 years down the road of doing something about the situation. And people say, well, what do we do now? And my feeling is it's too late. We're already seeing these changes, and as we keep putting greenhouse gases into the atmosphere, things are only going to get warmer. They're not going to get better.
And Michael, could this also be an Earth cycle?
No, it's almost definitely, I'd say definitely the result of the human-made CO2 and other greenhouse gases that are coming from energy use. Anytime you burn carbon in coal, in natural gas, in petroleum, you get CO2. There's no way not to have that. And as you use more fossil fuels, the CO2 builds up, and it acts like a blanket that holds in the energy, the climate energy, and it just gets warmer and warmer and warmer. The more CO2 you put into the atmosphere, the warmer it gets.
Does this mean we're going to have a very mild winter?
Could be, but one of the things that when you get this kind of climate change is you get more, I would say, unpredictable kinds of climate. So you might get a winter where you have an abnormally amount of snowfall because there's more moisture in the atmosphere because of the greenhouse effect, and so it's hard to predict. But I certainly predict that the summers, will continue to be as hot or hotter as they have been this summer and in the last couple of years.
This seemed to just creep up on us, didn't it?
Well, none of you were paying attention.
Not of you, or predicting, as you guys do.
Yeah, because the climate has been getting warmer and warmer every year. Every year has been warmer than the year before.
Why the big jump, though, on this one, this year?
It's hard to say. These things don't always go smoothly. and so there could be unpredictable jumps and tipping points in various aspects of the climate system. So there's no guarantee that the climate change is going to be gradual and year to year is going to be the same. You can get very unpredictable or sudden jumps in the climate warming.
Michael, 6 years ago, you wrote a book called Cataclysms, A New Geology for the 21st Century. How many asteroids have we tracked that we keep track of? Do you know what that number might be?
Well, we keep track of everything above about a quarter of a mile in diameter. And there are lots of them. And we keep track of most. We found most of them. And none of those that we found, when we plot their orbits into the future, has a collision with us, at least in the next few hundred years. But we haven't found all of them yet of that size. And, even something as small as a few hundred feet across, and we don't know where all of those are, is capable of taking out a city.
Well, that's right.
We know where a lot of the asteroids are, and we've plotted their orbits, and we don't see anything hitting us of that size. But the smaller ones, which can still do a lot of damage, can come out of nowhere. And a lot of times we see these things after they pass us by. They go, oh yeah, we almost had a collision with that one. And we see it after it's gone by us. So there's still a lot of unknowns in tracking these things.
Is it not a matter of just if, but a matter of when, isn't it? Because eventually one of these probably will hit us according to the odds.
Yes, absolutely. It's a question of when. Yes, and by tracking these things, we can see, hopefully, when. If we track their orbits into the future, and we know where the Earth is going to be. And then we find one, 100 years down the line is on collision with us. Then we know when, and then we can start to think about what we might be able to do about that.
Is blowing it up, Michael, worse than just letting the thing hit?
Well, blowing it up is not a good idea because you just have a lot of smaller things hitting all over the place.
It's like a shotgun.
Yes, that's right. So that doesn't really help. What you want to do is somehow divert it, right? And there have been some experiments now that have been done to see how well we could do that. Hit it with something and see if you can just knock it a little bit off course, and so that by the time it gets to the point where it's going to collide with us, it's off by a certain amount, and therefore it misses us.
On the ones we know about, if they're headed toward the planet, can they chart where it's going to hit and then give these people notice to get the heck out of the city?
I doubt if we'd have that kind of predictability and accuracy for something, small, relatively small, but big enough to wipe out a city. You only need something a few hundred feet across, and we don't know. They're very hard to see, and we don't know where all of them are. And so we find them, as I say, usually we find them after they've passed by us and we've had a close encounter. So I wouldn't guarantee that we'd be able to do anything about moving people out of the way or something like that.
Michael, would you be surprised if in a month we call you back to talk about an asteroid that hit the planet? I mean, is it that possible?
Yeah, certainly possible. Yes. Not a big one, not a dinosaur killer asteroid, not a mass extinction asteroid impact, but a small one. As I say, capable of taking out a city.
Where did these asteroids come from? Were they planets that didn't form, or a planet that blew up? Where did it come from?
Well, the asteroid belt is between Mars and Jupiter, and that's probably a lot of stuff that could have formed a planet, but didn't, because the gravitational pull of Jupiter, it's a very big planet, would have pulled that planet apart. So that's where asteroids come from, that asteroid belt, which, as I say, might have become a planet, but it was just too close to Jupiter to actually stay together. The comets come from way out in the outer parts of the solar system. They're mostly ice, and they come in occasionally when there's some perturbation out there, and it kicks one of the comets into an orbit that passes by the Earth.
What got you involved in all of this? This is great work.
Well, what got me involved in the geology and the study of the Earth in general was when I was 7 years old. They took me to the Museum of Natural History in Manhattan, and I saw, the dinosaurs, and I saw the meteorites, and I saw the gems and minerals, and I said, hey, this is for me. I want to know more about this stuff, and I stuck with it over the years, and it's worked out pretty well.
Did the asteroid that hit the Earth 60-some million years ago that wiped out the dinosaurs allow us as human beings to evolve?
Yes, well, it was important because the dinosaurs were dominant on the Earth 66 million years ago, and the mammals, the small mammals that were our ancestors, were living along with the dinosaurs, but they were just small, tiny, rat-like, mouse-like animals. And it wasn't until the dinosaurs were taken out of the picture that those little mammals got a chance to evolve into all the present-day mammals we have today in the world, including primates, including us. So we can thank that asteroid 66 million years ago for for humanity. We wouldn't be here today if that asteroid had missed the Earth.
Roughly how many asteroids are considered near misses that buzz by us every year?
Well, I think every year there's around 50.
Wow.
Yeah.
That are close enough to hit us if something goes awry?
Could be, yes. Most of them pass by closer than the moon, right? So they're pretty close to the Earth, but there's still a rather wide range there. So nothing that we know of now that we've predicted the orbits for is on a collision course with the Earth. But sometimes things pop out of nowhere and on strange orbits, and you never know when an impact might take place.
Michael, what about volcanoes? How dangerous are they to us?
Well, volcanoes most of them are dangerous for local and regional areas, right? If you're near the volcano and it's an explosive volcano that erupts, there's going to be damage and there's going to be a loss of life in the area of the volcano. But if the volcano is big enough, explosive volcano is large enough, what we call super volcanoes, then they can put so much material up into the atmosphere. That's the problem. When they explode, a lot of fine dust and droplets of sulfuric acid go up into the upper atmosphere, and they cut out some of the sunlight that will be coming and warming the planet. And so after historical eruptions, we've seen coolings lasting for a couple, 2 or 3 years after those eruptions. And when we do the calculations of what the cooling would be after a super eruption, which might last for several years, it would be enough to cause what we call a volcanic winter. And what that means is that the Earth would become so cool, so cold, that you'd probably lose a couple of growing seasons. And if that happened, there'd be mass starvation. And so that's a kind of civilization, not a mass extinction volcanic eruption, but it would certainly threaten civilization if you're going to lose, a couple of growing seasons. We don't have a backup of enough grain to get us through that kind of situation on a global basis. And so there would be a lot of trouble for the civilized world to get through that.
In Italy, in October 79 AD, Mount Vesuvius erupted, killing up to 3,500 people. They say maybe up to 16,000. They're not sure. Did those poor people have any notice at all, Michael?
No. That eruption, there were really no precursors that suggested that there was going to be an eruption. And so the eruption started in the morning, and it just went from there. And so there was really no real warning for the people in that area to try to get away. They were trying to get away during the eruption, but then, as you said, there was a lot loss of life, and those cities of Pompeii and Herculaneum were destroyed by the pyroclastic flows from that big eruption.
What causes a volcano to erupt? What builds up?
Well, there's these magmas that are inside the Earth are charged with gas. There's a lot of gas, CO2, and water vapor dissolved in these magmas, and as they come to the surface, that gas can be released, and it can be released explosively if the magma comes to the surface fast enough, and so that will cause an explosion. And so the magma doesn't come out as a lava flow; it comes out as particles, as pieces of pumice and fine ash and stuff. That's what's produced by an explosive volcanic eruption. And as I say, they're very hard to predict, and sometimes there's some precursory activity that allows you to say, well, there might be a big eruption coming, so maybe we better get people out of there. But very often there's not much precursory activity that tells you very much until the actual eruption.
What would you say, Michael, might be the biggest dangers to us on this planet now?
The biggest dangers? Well, I mean, of course, an asteroid impact would be the ultimate danger, but they don't happen that often. In the last really big one, it was 66 million years ago. That was the one that wiped out the dinosaurs. There've been some smaller ones since then, but so it's a rare event, which has a very big effect. And the same thing is true with supervolcanoes. They don't happen. They happen maybe once every 50,000 years. So they're relatively rare events. I'd say one of the biggest problems we have today in terms of sort of an existential problem for us is climate change. People have kind of ignored it or tried to ignore it for a number of years, but just look at what's happening this year. You can't ignore it anymore. You can't ignore the fires. You can't ignore the droughts. You can't ignore the super high temperatures. You can't ignore the very warm ocean temperatures that are going to wipe out the coral reefs. I mean, as you said earlier, it seems to be happening so fast, and I think it's because we hit a tipping point. Things were changing slowly, and then we hit a point where things started to change really fast.
In theory, if it's man-caused, it should get worse and worse and worse from here on in, right?
Well, as long as we're continuing to put...
If we keep doing what we're doing.
Yes. If we stop tomorrow burning fossil fuels, eventually it would start to get cooler. It wouldn't happen right away. But as long as we continue to put greenhouse gases, then I can't see us really cutting that down on a short-term basis. It's just going to get warmer.
Now, what's your definition of a greenhouse gas?
Well, it's the gas. There are a few gases which are greenhouse gases. CO2, for example, carbon dioxide, methane is a greenhouse gas. And what they do is they allow sunlight to come through the atmosphere and warm up the ground, and then the ground warms up and then warms up the atmosphere. And the heat that's coming out to warm up the atmosphere is trapped by the greenhouse gases.
I had heard that we had high carbon dioxide levels lots of years ago, many years ago. Is that true?
Oh, yeah, sure. 100 million years ago, CO2 was very, very high, and the planet was warm. But those changes took place over millions of years, slowly, gradually. The problem with what's happening now is it's happening, over decades, and ecosystems, life on Earth can adapt to changes that are happening that fast.
What's happening with the sea life right now?
I'm sorry.
Sea life, fish.
Well, if the temperatures in the ocean off of Florida are 100 degrees, that's reaching the limit of where lots of sea life can survive.
That's like cooking the fish in the ocean.
Coral reefs are dying. And once they die and the temperatures remain 100 degrees in the water, they're not coming back. And so that's a big, potential, very, very major problem.
What's a normal temperature for the ocean?
In the summer?
Yeah.
Maybe 80 degrees, something like that.
So it's 20 degrees hotter right now. That's amazing.
Oh, yeah. Yeah. Now, maybe in a few years, it'll be even hotter than that.
If we have cycles of winters, we could have a bad winter, though, right? Like you said.
Yeah, there's no guarantee that the winters are going to be any milder. It's the summer season that's the critical one.
And we've got another month of that, at least, don't we?
I'm sorry?
We have at least another month of that.
Yes. July was the hottest July on record, and I don't see why August wouldn't end up being the hottest August on record as well. I can make that prediction, I think, pretty safely.
Well, if this is caused by mankind, we're not going to change what we do any day quicker. So what happens?
Right. What happens?
Yeah.
Well, it'll just continue to get warmer. The more of these gases we put into the atmosphere, the warmer it'll get. So in San Antonio, it's 110 degrees, and here it may need to be 120 degrees, 130 degrees.
In theory, Michael, should it get worse next summer if things just stay the same?
I would say probably, since we're still putting more of the greenhouse gases into the atmosphere, we might expect it to be even warmer next summer.
Now, what happens if it's dramatically less? Then what do you say?
Well, there's always variability from year to year. But as I said, if you go back the last 20, 30 years, every year has been hotter than the year before. So there's a trend of warmer and warmer temperatures. And so this last couple of years, we've apparently hit a spot where we're seeing these very elevated temperatures. And as I say, this may just be a tipping point that we've reached. It's gotten warm enough so that there's so much extra heat in the atmosphere that we're seeing these very, very high temperatures across the whole world, essentially.
That's what really baffles me, Michael. This is not just a United States or a North American problem. This is worldwide right now. I mean, Greece is on fire. Everything's going crazy.
Well, the CO2 we put in the atmosphere is mixed into the atmosphere, goes everywhere. So we're putting CO2 in. China is, every country that's burning fossil fuels is adding to the CO2 of the atmosphere. That carbon dioxide is mixed around throughout the atmosphere. And so, you should see a fairly uniform warming.
I did not hear any meteorologists last year predicting this kind of weather this summer. Did you?
I don't think they predicted these kinds of temperatures, but I have a feeling they'll be predicting them for next year.
It'll be much easier to predict, that's for sure, sadly. Back to the asteroids for a moment. When you look at the moon, it's shattered with all kinds of asteroid holes and craters and things like that.
Yes.
If you dried out the planet Earth, the oceans and the vegetation, would we look the same?
No, because we've been hit by the same number of things. So there would be the same number of craters on the Earth, except that on the Earth there's erosion and there's volcanism and there are all kinds of things that would tend to erase the craters. And so there are about 200 known verified impact craters on the Earth, and we find a couple more every year. They're hard to find because they get buried, they get erased. But if there was no erosion on the Earth, if there was no geological activity, it would look like the moon.
That activity on the moon that shows all those craters, when do you think that might have occurred?
Well, most of it was early on in the history of the solar system when the planets were forming out of those pieces.
Four and a half billion years
around.
ago.
Yeah, maybe 4 billion years ago was this what's called the intense bombardment of the planets, when the moon and the Earth and the other planets would have been hit by a large number of, much more than we see hitting the planets now. And so a lot of the craters on the moon are old craters, very old craters.
When you think back at stories in the Bible, Sodom and Gomorrah destroyed, what they say, by God. Is it possible they got hit by asteroids?
Yes, George, it's very possible. And there was some studies last year of a city that had been destroyed in Israel, quite a long time ago, and there was some evidence there of impact that it may have been a blast, coming down from exploding in the atmosphere, or actually hitting the ground, that led to the destruction of that city, and it wasn't. It was never resettled again after that event.
If an asteroid hit the ocean, depending on the size of the asteroid, would that create a massive tsunami?
Oh yes, very, very massive tsunami. The asteroid that hit 66 million years ago. Well, it hit in the Yucatan Peninsula in Mexico, but that was underwater at the time, under shallow sea. And so that impact did set off a massive tsunami that went across the Gulf of Mexico and across the Caribbean Sea, and did a lot of damage on the islands there and on the coast of the Gulf of Mexico. So yes, there was a big tsunami with that impact that knocked out the dinosaurs.
Isn't there still a crater in the ocean where that one hit?
Well, the crater is actually on the Yucatan Peninsula, but it's buried. So when you make a hole in the Earth's surface, that tends to get filled in eventually by sediment. And so the crater is there, but if you go there, you don't see a crater, because it's buried under about 500 meters or so of younger sediment. You have to drill down, and then you drill into the material there. It's all melted and crushed and broken, and you can see the outlines of a crater.
Michael, this hour is going to fly by, so let's go to the calls. Let's start with Mark in Baltimore. Welcome to the show. Hey, Mark, go ahead.
Oh, thank you very much, George. How you been? And I'm looking forward to seeing you in October.
All good. Oh, you're coming to Columbus. Good for you.
Yep, absolutely. So my question is, and great guest, by the way, what do we know about the polar ice caps? We hear some stories from time to time, and we see the satellite photographs of how our caps may be suffering some melting in some areas. Can you tell us, what about the polar ice caps, and how are they doing as far as helping us keep the Earth cool?
Well, the problem is that as the Earth warms, and it's been warming, there's going to be a continuous melting of the ice caps in Greenland, in the Northern Hemisphere, and in Antarctica. And we see, from satellite images and from ground-based studies that in the last few decades, actually, and increasing in recent years, that there is increased melting of the polar ice caps, and that will, of course, cause sea level to rise, because the water from melting ice goes into the ocean and causes a rise in the sea level. So that's happening already as a result of the global warming that we're seeing.
They've been talking about the possibility of ice sheets melting very fast, raising sea levels. Michael, what do you think of that?
Well, that's very possible. Sometimes these ice sheets can surge, and especially if you begin melting at the bottom of the ice sheet, you get a water-based ice sheet, and then the whole thing can just surge off into the ocean, and eventually, pretty quickly melt. And so lots of people think, well, you usually think of the melting as being gradual, but that's not always the case. And as I've said about the global warming, sometimes you reach a tipping point, and things that were going along gradually suddenly go much faster, and that could happen to melting of the ice sheet.
Next up, let's go to Catherine in British Columbia, Canada, west of the Rockies. Hey, Kath.
Hi. How quickly would Earth be no more?
If we didn't have a moon? What do you think, Michael?
I didn't get exactly what the question was.
If we didn't have a moon, let's say it got blasted away,
yes?
What would happen to Earth?
Depending on how it was blasted away, I imagine chunks of the moon would hit the Earth, and there would be big impacts on the Earth as well. And if the moon disappeared, then there'd be some changes in the Earth's orbit, in its direction of its axis, tilt in space, and so things like that would happen as well if you lost the moon.
No tides, things would change that way too, right?
That's right. The tides would change, yes, absolutely.
Would it be devastating for us?
That's kind of hard to say. I haven't really given it much thought about what would happen if you lost the moon. It would certainly be significant changes. Devastating, I'm not sure.
What are the possibilities, all things considered, that we're in an Earth cycle that happens every 100,000 years or something like that?
Well, there are 100,000-year cycles in climate when we go from glacial periods to interglacial periods. So there are 100,000-year cycles, but that's what we're seeing now in terms of this global warming is not a 100,000-year cycle. It's happening over decades.
Neil's in Santa Monica, California. Take it away, Neil.
Hey, how's guys doing?
Okay, Neil.
Yeah, so I never hear you guys talk about that. It's animal agriculture is what causes all the methane. Methane traps 84 times more heat in the atmosphere than carbon dioxide. We raise 100 billion farm animals, and that's the methane comes from not only the manure, but the runoff of the fertilizer into the ocean, which causes massive hundreds of miles square dead zones.
Michael, we have not talked about that. What do you think?
Well, methane is definitely a greenhouse gas, a very strong greenhouse gas, and anything that puts methane into the atmosphere will induce significant global warming. And there is methane coming, as you call it, suggested, from raising animals, especially beef. So there's an input of another greenhouse gas, which doesn't help the situation, just makes things worse.
But alone by it, it's not the cause.
No, that wouldn't be the major cause of the global warming. That would be we put so much carbon dioxide into the atmosphere by burning, coal, oil, and natural gas that it dwarfs the methane effect. Although the methane effect is there.
Michael, the couple of your books are still available?
Yes, Cataclysm is certainly still available. Yes.
A New Geology. How long did it take you to write that one?
About a year.
That's not bad. Are you working on any new stuff?
Yes, I'm working on one now about cycles in the Earth history called The Pulse of the Earth.
The Earth does have a pulse. It's almost like a human being, isn't it?
Well, it has a pulse. There are cycles, and cycles of geological activity, pulsations. So in that sense, it's sort of like a living thing, but it's the pulses of geological activity, not biological activity.
Michael, we all have heard about Halley's Comet. Comes around every 76 years. How many comets come into the solar system?
Well, that's an interesting question. It probably varies, and in fact, there may be cycles to it as well. Some people think that there are actually times when there are comet storms, when you have a relatively large number of comets coming into the inner solar system where the Earth is, and then the Earth has an abnormal number of comet impacts. And so the number of comets probably varies, certainly from year to year, but maybe even in longer cycles as well.
Are they massive in size? How big are they?
Average about 5 miles in diameter.
That's pretty good
Like
size.
that. What's that?
That's pretty good size.
Well, that's about the size of the asteroid that hit the Earth and killed the dinosaurs.
That's right.
So if we got hit by a comet that big, it would cause the same kind of disaster as we saw with the dinosaurs. It would cause a very large explosion because when the thing hits, it actually explodes, and it would produce a global catastrophe. So we have to worry about not only asteroids, which are made of rock, but also comets, which are probably mostly made of ice. But it doesn't matter what it's made of. It's traveling so fast, has so much energy that even if it was made of whipped cream, it would hit the Earth and explode and cause a disaster.
Do we know if we've ever been hit by a comet?
Well, in the 1908
Tunguska.
explosion in Tunguska was probably a piece of a comet, small piece of a comet.
That blew up in the atmosphere and charred everything, right?
Knocked down all the trees in a circular pattern and charred them, and it was an explosion in the atmosphere. The thing blew up above the surface of the Earth, and so, but it was probably a comet.
Now, why do you say that?
Because it didn't leave any rocky material. It didn't leave any residue in the area. And so the thinking is that if it was ice, then it wouldn't leave any rocky material. The ice would just evaporate into water vapor. And so that's why we think it was probably a comet.
How did a comet form in the first place?
Well, they form way out in the outer part of the solar system, way away from the sun, where it's very cold. And so over time, these probably formed very early in the history of the solar system when the planets and other bodies were still accreting out of smaller particles. And these things accreted out of smaller pieces of icy material. And they remain out there in this cold part of the solar system unless something comes along and perturbs them, and then they fall in towards the sun, and that's when they might hit the Earth.
It's a frozen water ball, isn't it?
Pretty much, yes. Maybe a kind of dirty snowball. People call these things. Has some rocky stuff in it, but it's mostly ice.
Back to final calls. John in Alberta, Canada, east of the Rockies. Hey, John, go ahead.
How's it going?
Good.
I was just curious, wouldn't the fires here in Alberta have the exact opposite effect of global warming? Wouldn't they create like a blanket of that kind of stop the sun from heat reaching us, or am I just being crazy?
You're not crazy, but go ahead, Michael.
Well, no, the fires, the smoke has the ability to cut down on the incoming sunlight, but it's a relatively small effect compared to the warming effect of the carbon dioxide in the atmosphere. So, yes, there is an effect, but it doesn't outweigh what's happening in terms of global warming.
Doesn't it give you, though, like a blanket, which is just as bad?
I mean, in terms of keeping in the heat?
Keeping down everything, yeah.
Yeah, it has some effect on that as well. And clouds do the same thing. They reflect back a lot of sunlight to space, but if they're low clouds, they keep the surface of the Earth warmer. So they have both kinds of effects. And smoke, depending on the altitude and the density and other characteristics, may have a warming effect or a cooling effect, depending on where it is and what it's made of.
Let's go to Eric, truck driving in Indiana, one of our favorite states. Hello, Eric.
Hello, George. The guy just asked my question, but I'll make a comment.
Sure.
I've been around here for 63 years. I lived in Indianapolis all my life and saw a lot of change in Indianapolis due to of all the trying to control emissions control, and we've came a long ways of cleaning up the emissions on everything, because I've seen in my town alone 4 plants closed. Ford, Chevy, a gas plant we had there in the middle of town, it stunk to high heaven. And, Lilly used to have a bad smell in our town, too. And they've cleaned up themselves, too. So I'm just wondering, here we are, we're still on the same subject, how far do we need to go before we get this thing, before we actually have confidence in our air quality, you know what I mean? And as far as a blanket, when he was talking about a blanket of smoke from the fires, look what we're breathing. We're breathing. Does all that exhaust off of the cars and stuff still stay down? I mean, we're breathing the smoke and the exhaust about the same time, really.
How polluted are we, Michael?
Well, the exhaust problem is much better than it was years ago because of the catalytic converters. So there's not this problem with nitrogen compounds, pollution. The smog kind of pollution that LA used to have all the time. It's chemical pollution. Once we put in the cars the new technology, we cleaned up a lot of that. That's why a lot of the cities now are a lot cleaner. But of course, the fires are causing a whole other thing. The smoke from the fires, and that's independent of what's going on with exhaust from cars and things like that.
Yeah, that's just ruining the air quality.
Yes. Well, as long as the fires are burning, yeah.
Let's go to Ed in Texas. Hey, Ed, thanks for calling. Go ahead.
Hi. What effect does water vapor have on greenhouse gas?
Water vapor on greenhouse gases. I don't know, Michael, do you?
Yes, the water vapor is a greenhouse gas, but water vapor, can only build up in the atmosphere so much until it condenses and becomes rain. And so it's not a major greenhouse gas because it can't accumulate as vapor in the quantities that CO2, which does not condense and form a liquid, the CO2 can. So water vapor, yes, it's a greenhouse gas, but it's not the important greenhouse gas in causing the global warming.
Is China the worst offender of all of this?
Right now, yes.
Still. Are they doing anything to better it?
I don't know exactly what's going on in China, but they're still producing a lot of carbon dioxide and other greenhouse gases. So, as long as that we're burning fossil fuels, we're increasing those gases, and that's not going to reverse the warming. It's only going to make the warming worse.
Let's go to Janet in Manhattan in New York. Go ahead. Hi, Janet. Go ahead.
Oh, hi. Yes, I have a question also about the coral reefs. I'm curious,
Sure.
You mentioned in answer to the other woman's question that it was the 91 degree temperatures of the water that were killing the coral reefs. But I'm wondering also about the acidification of the ocean. First of all, what causes the acidification? Is it that so much more carbon dioxide than there used to be, or maybe that amount of carbon dioxide could have been harmlessly dissolved into the water, but the heating of the water becomes like a catalyst to create a chemical reaction between the carbon dioxide and the water, creating carbonic acid, and what effect does that have on the coral reefs? So I'll hang up and listen. Thank you.
Okay. Well, you're right about the carbon. It's the carbon dioxide that we're putting in the atmosphere that eventually some of it gets dissolved in the ocean, and that increases the carbonic acid acidity of the ocean waters. And so the problem of putting CO2 in the atmosphere is also exacerbating the ocean acidity problem, and that's another problem for coral reefs, because they build their skeletons out of calcium carbonate, and if the waters are too acidic, then the corals will not be able to build their skeletons in the way they normally do.
Next up, Larry's with us in Sacramento, California. Hello, Larry.
Good evening, George. I really wanted to talk to you and your guest about the real cause of global warming, which is the upcoming magnetic pole flip.
Magnetic pole
flip.
It's
been proven by geological surveys that it happens every 300,000-400,000 years, and it's overdue.
It does happen, but Michael, would that contribute to global warming?
Probably not. It may have other effects on the environment, but I don't think that a flip of the Earth's magnetic field is going to exacerbate or change the global warming situation. I don't think there's any evidence that is a probable thing that's going to happen.
Let's go to Wayne in Tacoma, Washington. Hi, Wayne-O, go ahead.
Good evening, gentlemen. Sir George and Michael. First, I need to give a shout-out to my mother, her 105th birthday this week.
105? That's fantastic.
It's amazing. She's an amazing woman.
That's excellent.
And still has her own apartment. And then our friend Cornelius, of course, in Louisiana, Mike in Denver, and Mr. Barry Poole. He needs prayer because he's in the hospital now.
Who is he?
Okay. Michael, I wanted to ask you, have you taken in global volcanism in your considerations of pollution on Earth? I know this year we have, so far, 56 active volcanoes in 26 countries. Last year we had 80 active volcanoes in 28 countries. And we know that each volcano, like, for instance, Mount St. Helens, they said the explosion of Mount St. Helens was equal to more than 10,000 nuclear bombs, and it puts every day it puts more pollution in the air than all of the cars of the world for a year.
It's a lot of pollution, Michael.
Yes, well, it's pollution is different from carbon dioxide, right? Carbon dioxide is not considered pollution. And so there are other gases, sulfur gases, for example, that come out of volcanoes, sulfur dioxide. So if you're around an active volcano, you have trouble breathing. And those can pollute the atmosphere, the sulfur gases. The CO2 is not considered a pollutant. It's just something that builds up in the atmosphere. It's an invisible gas, so you don't see it. You don't see any effects of it, except that it's increasing the heating of the plant.
Michael, what happens next? What is science going to do about all this?
About what?
This problem
of global warming?
Of course.
Well, as I said earlier, I think in the short term, there's very little we can do. I mean, what we need to do is get off of carbon fuels, but that's not going to happen overnight. That's going to take a considerable amount of time and effort to do that. And so until we do that, we're going to still be putting out a considerable amount of greenhouse gases like carbon dioxide, and so the climate will get warmer. And there's no magic bullet, there's no magical thing that we can somehow stop the warming from taking place. It's not going to happen. There's no technological, miracle cure for this. And so in the short term, if I had to predict what's going to happen, is that the Earth is going to continue to get hotter. And there's not much we can do about that in when we're talking about 10, 20, 30 years until we can stop putting more CO2 into the atmosphere by burning fossil fuels.
Will there be extreme temperature changes? Like, could winter be a record cold?
Well, winter could be a record warm. We could start to have relatively warmer winters. I don't know much about winter temperatures and what they've been doing. I know more about summer temperatures, which you can see have been getting hotter and hotter. But I'd have to look into the data to see exactly what's going on in the winters. But I can tell you that in the last, since the 1970s at least, almost every year, if you have the whole yearly temperatures, which include the winter and the summer, every year has been warmer than the year before. And so the trend for yearly temperatures, and part of that is summer and part of that is winter, of course, have been getting warmer and warmer.
Michael, keep in touch with us. Let us know when your book on Earth's Pulse is finished. The Coast mobile app is now available for download on iPhones and Android devices. You can become an insider directly through this app. This is a great option for our international listeners, and new users will also receive a free 2-week trial.